Good morning, 6th graders. Welcome to Chapter 3.4, Solving Equations with Variables on Both Sides. It's very important that you get this down in your notebook and you really see the steps that I take to solving these problems, because we're used to taking the reciprocal when it's in front, the reciprocal of a fraction when it's in front of a parentheses, but we talked about when you don't need to take the reciprocal of that, and you'll see that today. So pay attention. So what does this mean? Some equations have variables on both sides. To solve such equations, you may first collect the variable terms on the side with the greater variable coefficient. Okay, let me read that sentence again. This is a very important sentence right here. You may first collect the variable terms on the side with the greater variable coefficient. So remember, the coefficient is the number that occurs before the variable. Okay, so we want to collect those first on one side. Okay, so go through our steps again. We want to first simplify each side of the equal sign. And if it's already simplified, then we want to collect both sides of the equal sign. We want to collect the variables on one side of the equal sign. Okay, and with the greater variable coefficient. We do that because we want to have a positive variable. Okay, so let's take a look and I'll show you why. So here's some examples. Let's solve this. 7x plus 19 equals negative 2x plus 55. Well, by the definition, I'm looking at the coefficient. We have a 7 and we have a negative 2. So the 7 is greater, so I'm going to bring this negative 2x over. And I bring that over by adding 2x. So we know that 9x plus 19 equals 55. And now we're used to solving problems similar to this now. So we subtract 19. Because we're trying to isolate the variable. 9x equals 36. Divide by 9, x equals 4. Now, it's very important that you plug it back in. Okay, so when I plug this 4 in for the x here and the x here, I should get the two numbers that equal each other. So 7 times 4 is 28. 28 plus 19, 47, equals negative 2 times 4 is negative 8 plus 55, which is 47. So 47 equals 47, that checks out. 47 does equal 47. Okay, go step by step, check it out. So here we go. On the right side here we have 80 minus 9y equals 6y. So simplify each side of the equal sign. So I'd call this side 1, side 2. Okay, they're both simplified, so we can start working to isolate that y variable. So we have a negative 9 here, because we usually write this as 80 plus a negative 9y equals 6y. So remember the greater coefficient. So we have a negative 9 as a coefficient right here, and we have a 6. So we want to bring this negative 9 over. 80 equals 15y. Not 115. 15y. Divide by 15. And y equals 5 and 1/3. So you can write that as 5 and 1/3. 5.3 repeating. Either way you want to write that, you get 5 and 1/3. Now that's a little bit tougher plugging it in to double check your work. So you may want to use a calculator at this point to double check your work. Okay. So many solutions are no solutions. Linear equations do not always have one solution. An identity is an equation that is true for all variables of the all values, for the variable. Some linear equations have no solution. So let's look at the one here on the left. 3 parentheses x plus 2 equals 3x plus 6. So I know the first step here, I have to distribute this. 3x plus 6 equals 3x plus 6. Okay, so I noticed something right off the bat here, that both of these equations are the same. So if I was going to get the variables together, well, the coefficient is 3 and 3, so it doesn't matter which side you bring it on. We see something that happens. Both of these variables actually cancel each other out. So 6 does equal 6. And this is what we'd call an identity. Okay, the variables cancel each other out, and the only thing you're left with is a number, and it is 6 equals 6. So that is an identity. And again, that means I could plug in any number for x here, and I would get the same solution on both sides of the equal sign. So try it in your head if you want. Plug in 100. Plug in 500. Plug in 6 for x on both sides. You will get the same solution. So let's notice something on this side. So I know I have a coefficient of 1, coefficient of 1. So subtract x, doesn't matter which side. So cancel out, cancel out, cancel out, cancel out. 2 equals 4. Okay? So notice 6 equals 6 here, so that made sense. 2 equals 4 here. That does not make sense. So this one would be a no solution. And that's why it's so important that you check your work and you put your answer back in. Because if for some reason I made a mistake with this and I plugged it back in, let's say for some reason, let me rewrite this to show you. Let's say for some reason when I subtracted this over, I did the right step, but I put 2x here, plus 2 equals 4, subtract 2, 2x equals 2, x equals 1. In my head I'm thinking, oh yeah, that makes sense. X does equal 1. But when you plug it back in, we're saying that 1 plus 2 equals 1 plus 4. So we're saying that 3 equals 5. And that does not make sense. So no matter what variable you put in for this problem, for x, what value you put in for x, it will never work out. Both sides of that equal sign will never equal each other. Different than what occurs here. You can plug in any value in that equation and you'll get the same solution. Okay, so that's called an identity. It's very important that you write these definitions down and give yourself an example of what that looks like. So we could have a one solution. This is what we'd call a one solution. One solution. Okay? Then you get an identity, which identity means that really all real numbers. And we have no solution. So more examples. These are a little bit more complicated, involves a little bit more. So let's work on the one on the left first. 4 parentheses 1 minus x plus 3x equals negative 2 parentheses x plus 1. So first thing we have to do is distribute. So we get 4 minus 4x plus 3x equals negative 2x minus 2. So combine like terms first. That's my first step, always. Now, this is where it's very important that you watch. Okay, I didn't do a good job here. I should include the sign as well. Okay, this is a negative 4x. So we have negative 4x plus 3x. So it's really saying negative 4 plus 3, which we know is negative 1x, equals negative 2x plus or minus 2. So look at our coefficients here. Where would I want to bring it over? We have a negative 1 coefficient here and negative 2 coefficient. So actually negative 1 is greater than negative 2, so we want to add 2x over, and that's why you bring it over to the greatest one so that your variable, even if it's negative, your variable will end up being positive now, which we want. Don't forget this negative sign is connected to this 2, so you got to bring that down as well. So subtract 4, I'm running out of room here, but x equals negative 6. Now you have to check your work. Plug it back in. Okay, so if I plug in -6 here, -6 here. So let's work on the left side of the equal sign first. Sorry about that. We have 1 minus a -6. So we know that these turn into a plus. I have to plug in -6 here too, sorry. So it is saying 1 plus 6, which is 7, which is 28. 28 minus 18, because 3 times -6 is -18. So I get 10 on this side. So I'm hoping to get 10 on this side. So -6 plus 1 is -5. So -2 times -5 is 10. So 10 does equal 10. And this answer of x equals -6 is correct then. There's only one solution for this problem. So over here, this is kind of what I was talking about earlier at the beginning of this video. Okay, we talked about this the other day in class. If I have a fraction on the outside, my goal is to either A, distribute it and get whole numbers out, or take the reciprocal of that. So the first one I want to check is always to see if I can distribute it and get whole numbers out. And on this problem I would. If I distribute 1/4 to 12 into 16, I get a solution of 3x plus 4. Okay, 1/4 of 12, so 1/4 times 12, and then 1/4 times 16, you get 3x plus 4 equals 10. Now you're distributing the -3 to both of these, so -3x plus 6. So combine like terms first. 3x plus 4, there's no like terms on that side. We can simplify this side though, so you get 16 minus 3x. Largest coefficient is 3, so I'm going to add 3x over, add 3x over. I get 6x plus 4 equals 16. Subtract 4, 6x equals 12. Divide by 6. Run out of space again, sorry. These problems are getting larger, that's why you have to show all your work. X equals 2. So plug it back in. 2 and 2. I get 2 times 12, which is 24, plus 16. 24 plus 16 is 40. 1/4 of 40 is 10. 2 minus 2 is 0. 0 times -3 is 0. 10 minus 0 is 10. So I get 10 equals 10. And I did not plan that to work out, but that's just how it works out, I guess. So x does equal -2. Okay, go step by step, plug your solution back into the problem at the very end to double check, because some may be an identity, some may be no solutions. Okay, here's your homework. 3 problems. 6x plus 22 equals -3x plus 31. And then 4 parentheses x minus 5 equals 4x minus 20. And then 2/5 parentheses 10x plus 15 equals 18 minus 4 parentheses x minus 3. So if you have any questions, please email me. Just take your time. Okay, it's very important that you take your time and watch your work. Watch the steps that you're performing, and really make sure that you take the greater coefficient and bring it over to that side. Bring it over to the greater coefficient. Okay, keep the x hopefully positive. Alright, so I hope you have a wonderful evening, and I will see you again on Wednesday. Take care.